Okay, so we'll take a look at our calendar, which keeps changing. So Monday, we had another snow day, so I've put a new calendar on your desk. So go ahead and grab a copy of the new calendar and discard the old calendar. It is no longer in play. So that means that on my math lab, I've pushed back the dates of assignments so that they're due just a little bit later now because we missed another day of classes, okay? But hopefully you have started and maybe finished homework number 3 and potentially started and working on homework number 4. That was the one that was assigned last class, okay? Today we cover class number 5, all about slope. Any questions on the calendar? All right, and one other observation about the calendar. So today's Wednesday. Friday, we talk about equations of lines. Monday coming up is President's Day. There are no classes meeting on Monday. It's a scheduled Monday off. And then Wednesday, 1 week from today, is our very first quest. It is a full period, bigger than a quiz, not quite on as much stuff as a test. That's our first in-class assessment. Questions on anything? Okay, so before we jump in on page 32, just one quick announcement. I was asked to share this information with you guys. It's about the recycling bins that are in all the classrooms here. It's a single stream recycling program, which means you can put lots of different kinds of recycling things into this one bucket. So we just ask that you think about something before you either throw it in the recycling bin or throw it away. Recyclable things include clean paper and cardboard, empty glass and plastic bottles, and empty cans. And then stuff that should not get recycled, but rather should go in the trash, is the list of things in that, the things in that list. So I don't expect that you'll memorize that. So I printed it out, I put it right here on the wall. So as you come up here to the recycling bin, just take a quick look. Is it recyclable or not? And make your choice, okay? All right, so again, jumping here at the top now of page 32, the daily summary. Can we go to Alex? Kayla? Thank you. Jeremy, number 1. Okay, thank you. So the 2 diagrams are actually drawn and labeled there. So I'm going to ask you guys to just cross the second one off. We're going to draw it from scratch. I just want to make sure we can draw it because this might come up on a test or request. So let's just highlight the ideas for the first drawing, which is already done there. It says the first road, A, climbs 120 feet. So that climbing tells you that we're talking about the vertical change. And then it says over a horizontal distance of 4,250 feet. So the horizontal is clearly that guy right there. So there's the diagram, right? So if you are walking or driving along that road, you are climbing 120 feet over the course of 4,250 horizontal feet. Clear? Okay, also note that this diagram is wildly out of scale. 4,250 is roughly 40 times, right? 40 times that 120, and that is not accurate in this picture. It's okay, and we're going to be doing some calculations here, but I just want to highlight this is not to scale, not even close. Okay, let's try drawing a similar diagram for road B. So again, don't even worry about the scale. Here's road B. I've got 2 numbers, 95 and 2875. Which one goes on the vertical? Is the 95. It says we climb 95 feet, so we'll put 95 over there. And then I guess that means the horizontal is 2875. So there's road B. And the question in front of us here is which road is steeper? So we can see that we're climbing not very much for a lot of horizontal change, but which one is steeper? Well, we kind of need a sense of how the vertical compares to the horizontal, right? I said it was roughly 40 times. The horizontal was about 40 times the vertical, but we can calculate exactly what that number is. And in fact, what we're going to do is calculate the reciprocal of that number. It's down here. We will calculate the steepness of each line by finding the ratio. Ratio means what in math? Add, subtract, multiply, or divide. Ratio means divide, right? Find the ratio of the vertical change to the horizontal change. That word to tells you which one goes on top. Vertical or horizontal? Vertical, right? The thing before the word to goes on top, after goes on the bottom. So we're going to do vertical over horizontal. Here's the calculation for road A. The vertical in road A was 120, divided by the horizontal in road A was 4250. I typed it into my calculator, I got 0.028, okay? So in some sense, that is a measure of the steepness of the line. Again, I said we could have done the division the other order, but we're going somewhere good with this. So we're always going to be doing vertical on top, horizontal on the bottom. So let's fill in the same calculation for B. Again, vertical on top. So what's the number on top for B? 95 divided by 2875. Somebody with the calculator help us out here. Savannah says 0.033. Okay, so what that means is that road A has this number 0.028 and road B has this number 0.033. And those numbers tell you what part is the vertical out of the horizontal. Can you look at those numbers and just decide which road is steeper? Which one, A or B? It's B, because it's got the bigger number. Now, that's not an easy question to answer. Like, you really got to think about what are those numbers saying. We could think of them as percentages. This 0.028 is really 2.8%, right? What that means is that the vertical part is 2.8% of the horizontal part. Yeah, we all have a sense of what that is. And then over here, the 0.033 is 3.3%. The vertical part is a bigger percentage of the horizontal part. There's more up for the same amount of horizontal. And if there's more up, it's steeper. And so that sentence is written out here. Since the steepness of B, that 0.033 is greater than the steepness of A, which is the 0.028, road B is steeper. All right, so put it all together into a definition in number 2. Let's go to Will. Delta. Great. So here are a bunch of different ways we can think about this new concept of slope. I'm defining something new here, although I think many of you have seen this word before, but we use the letter M to indicate slope. It is always the change in the y coordinate, the vertical, divided by the change in the x coordinate, which is the horizontal. In symbols, delta often stands for change in, so delta y over delta x is a shorthand way to say the same thing. And you might have also seen it as a rise over a run, okay? Lots of different ways to talk about that same steepness number. Okay, let's go to Tyler for 3. Okay, so we saw this graph in a previous class. The y-intercept up here looks like it's 0, 800. What does that mean? So we're starting 800 feet up, and the word starting captures the 0, right? T equals 0 is our starting moment in time. And then the x-intercept or horizontal intercept looks like it's 4, 0. What does that mean? For what? 4 minutes into our trip, what happened? We touched the ground. The height is 0, altitude is 0. Okay, so we're going to choose any 2 points on the line. So the choice that I'm making in this calculation is 0, 800 and 3, 200. So that's these 2 points here. I'm going to ask you to pick 2 different points in just a minute. But those are 2 points that we can pick that are on the line. And for those 2 points, we're going to use our new formula up there to find the slope of the line. Okay, so again, slope, we use the letter M. It is always defined as the change in y over change in x. So when we talk about change in, change in y over change in x. So we've got this shape right here. And now all of a sudden it looks like my road. And so how much is the vertical change between the two blue points? It's 600, right? Because it's 800 at the top and 200 at the bottom. So that vertical change is 600, and you can just write that out with a subtraction, right? 800 minus 200. And on the bottom, what's the horizontal change? This piece here is 3. But there's an easy mistake that you can make. If you just put 3, you're going to get the problem wrong. And so when you write it out formula-wise, 800 minus 200, that's there and there. And I just want to highlight that we are subtracting in that order, 800 minus 200. And if we choose to subtract in that order for the y's, then we are obligated to subtract in the same order for the x's. So it shouldn't be 3 minus 0. What should it be? 0 minus 3, which is negative 3. So 0 minus 3 you can see at the bottom. Negative 3 is down there. 600 over negative 3 is negative 200. That's the slope. Okay? So the slope of this line, according to those 2 points, is negative 200. But in part C, I'm going to ask you guys to pick 2 other points, not the points that I picked, but 2 points of your own choosing. So with your neighbors, can you guys pick 2 different points, neither of these blue points that I've picked, and then go through the same slope calculation, and we'll come back together in a minute. Okay, so I just walked around and the different tables all picked different points, or I should say no table picked exactly the same 2 points. Some of you had the same point, 1 point the same, but nobody had exactly the same 2 points. This table over here, what did you guys get for your slope? Negative 200. Table in the back, what did you guys get for your slope? Negative 200. Here in the front, what did you get? And in the front here, negative 200. And the idea is that it doesn't matter what 2 points you pick, the slope of the line is just some number. And as long as you do the calculation right, you will all get exactly the same number. Okay, so that's what we just did there in E. Let's take a look at F. We'll come up here to Christian for F. Okay, is everybody comfortable with these units? When we did the 800 minus 200, both of those numbers were in feet. And when we did the 0 minus the 3, both of those numbers were in minutes. So if we just copy the units down, we'll see that we got feet on top, minutes on the bottom. And as soon as you see feet divided by minutes, you might even change this symbol to what word? Per. Yeah? Feet per minute is a very natural thing to say. Yeah? Feet per minute. And all of a sudden, that negative 200 has a context. It has a meaning. Okay, so I've got 3 different versions of sentences using that negative 200 feet per minute, explaining to somebody not in an algebra class what that number means. Okay, so here's a good sentence. The balloon's altitude was changing at negative 200 feet per minute. It's true, it's full credit. Here's a better sentence. The balloon's altitude was decreasing at 200 feet per minute. How do I know it's decreasing? Because it was negative 200, right? That negative really means we were going down. We were going back down to the earth. And I also want to highlight that if you said decreasing at negative 200 feet per minute, that's a problem. Because the word decreasing includes the negative part of that number, and you can't have both. Okay, and then finally, maybe the least awkward of these sentences, the balloon was falling at 200 feet per minute, right? So any of those is fine. Oftentimes you'll write your sentence initially and then you'll improve it once you really understand what's going on. Okay, number 4, let's go to Savannah. Okay, so that's one way to make a mistake. There's really only 2 ways to make a mistake in slope, and one of them is to put the wrong thing on top. Always y on top. Stephen for B. Okay, so that first fraction is what we actually did. The second fraction is us saying 200 minus 800 in that order. Great. But if we do that, then what order do we have to do for the x's? So what minus what? Would have to be 3 minus 0, right? If you do, you got to do the same order, top and bottom. So either of these will give you the same answer, negative 200. But the last guy is the problem one. If we do on top 800 minus 200 there, and on the bottom 3 minus 0, you can see that we are not doing the same order. And you're going to get the wrong answer. You're going to get positive 200 in that case, which just isn't right. Any questions on slope? Okay, so activity starts on the next page. I will walk around and help if I can.